So this presentation was made by Dan Brown. So he was the TA the year that I took this class. So I remember this presentation actually. And he's kind of like Sheldon in the Big Bang Theory. So that might give you some insight. So this is episode 4.35, natrium and calcium. Do you guys know what those things are, natrium and calcium? So natrium is sodium. That's why it's Na. It's Greek, correct? And calcium is potassium. That's why it's K instead of PO or something. Alright. So, we're asked to make a process that gives us pure sodium, or natrium in our case, right? So when we're looking at this, we know where we're starting. They're really nice and they already gave us our start point, so that's good. And they also tell us some interesting things about what type of separation is available, right? So what kind of separation can we do? Does it say? Yeah, well.
Liquid, liquid, and solid liquid.
We can do liquid, liquid, and solid liquid separation. Okay. So what can't we do then?
Solid, solid.
So that kind of gets rid of these two areas for us, right? Does that make sense? Right off the bat, we can't be separating in these areas. So that's a good thing to know going ahead. All right. So the next thing that we might want to look at is we can only change the temperature of this incoming stream, right? We're not going to be changing the weight fraction, so we're not going to be going up and down this axis right away, but we can be going up and down this. So which temperature gives the highest flow rate of pure sodium? A, B, or C?
C.
C? And why is that? Yeah.
Because the ratio of the lever arm is the longer lever arm.
So which, the left side or the right side? Which side of the lever arm am I concerned with when I'm talking about pure sodium? The left side. So I'm concerned with how long this side of my lever is because I'm dealing with what's on my mass that's on this side, right? So you guys are right. The C is the longest one. So how do we find it? So basically now we brought our temperature down. It's about 7 degrees Celsius. How do we know our two compositions of these two outputs that we have? Where can we read off those compositions on this graph? Yes.
Bottom.
Yeah, we're just going to drop them down, right? So we know we have about 44.8% of sodium right here and pure sodium on that side, okay? So that's pretty good. It's a pretty good process we have. This is our process. Basically have a separator. All right, so we've produced pure natrium. Cool. All right, the weight. We want to maximize our production of natrium. So let's look at our process again. So basically, if you're thinking about this process, how can we maximize, if we think about an overall mass balance on this process, how can we maximize the amount that comes out over here on this side? By going as far this way as possible. Does that make sense? Because if you just did like one overall mass balance, if I had this part be my fulcrum and I have a mass on this side and then I have a mass over here somewhere, the longer this line is for the overall balance, the more sodium I'm going to be getting out there. So almost inherently they're asking you to try and go as far to pure potassium as possible. So how would I just go all the way over here? Just if I drop this down and just go all the way here. How does that sound? Why not? Yeah, Brittany.
So we can't separate solid from solid?
Right, so I can't separate this. So what's the farthest place to this direction that I can separate? Yeah.
The liquid region?
The liquid region? This liquid region?
Yes.
So if I was up here, but can I separate this liquid? No, there's no separation here, right? So if I exist as a point in here, I just exist there. I don't get to split. Only in these two phase regions do I get to split. So, yeah, Rachel.
I can take it down to the liquid, solid, Na2 region.
Here, okay. So basically, if I take it down to here, then I can split that off into 2, right? And this is as far this way as I can go on this. Does that make sense to everyone? But if I'm going over here, so right now I'm getting pure Na2K out. So this is only beneficial to me if I'm doing what in this process? Yeah.
You want to take the 4 back up to the solid.
Yeah. Okay. So this is what we have. We're getting that solid Na2 and that 20%. And so that's what our process collects. And you guys just said, oh, this is Yoda. He comes up. So you guys know what your final challenge is. You want to get pure Na2. And so that's why you guys know that you have to recycle this back up, right?
Yeah.
So we have to go all the way over there. All right, cool. So I have this. So I have this process, and I'm done. Or am I? Anyone see anything I can improve about this process? Like things that I need with recycles, maybe. A purge. Good job. Okay, so one other thing that I want to look at with this process. So I have my input, right? And I have my 2 outputs. So in order to actually run this process, I'm going to have to get a cooler to cool this to here, to about 7 degrees, and I have to get another cooler to cool this to here. So what would you guys think if I, instead of going all the way down to 7 degrees, went to around like 20 degrees and split it there and there? How would that affect my process? And then I just recycle this loop instead of having that one. How would that affect my process? Dan?
That's less solid sodium you're getting.
Why?
Because if you look at the percentages and like that liquid that you're going to be getting on the left side, instead of being like 45% sodium, it's going to be like 55% sodium. So it's obviously more sodium that's going to be going in there.
But what is my 2 outputs still? This is my output,
Yeah.
which is the same, right? It's still pure. And this is my output, right?
Yeah.
So my 2 outputs are the same, and my input is the same. So if I do a mass balance on my system, my output of sodium, pure sodium, has to be the same. I'm not changing that. So we know, based on mass balances, that this has to be the same. So why is that the case? What's changing about the inside of this process that's making that true? Rachel?
Are you making more Na2K solid?
Yeah, so because I'm going here, if we look at this tie line down here, now I'm making this much Na2 solid instead of this much, because the mass here is proportional to my line here. So earlier I was making this much, now I'm making a bunch more. But what am I doing with that? Just recycling it. So basically this recycle is becoming really big, right? That recycle is coming really big. But what would be the benefit of this? I get to operate at around 20 degrees Celsius. I only have to buy 1 cooler instead of buying 2. So I can take this to 20 degrees. My recycle comes bigger, but because of an overall mass balance, my 2 outputs stay the same. Does that make sense to everyone? Basically, I could push myself all the way, as far up here as possible to get closer and closer. But as much as I push myself up here, my recycle gets larger and larger. Okay? Does that make sense to everyone? Questions? Okay. So then my new process is basically the same. We also have purge, but except for I'm doing this first separation at 20 degrees Celsius instead of doing it at 7. So I don't have to cool this stream down. Okay? All right, we're done. Or are we? We're done. Okay, cool. Good.